Okay, welcome to matrix multiplication, our second part of our video here in 8.4. If you read the definition, let A be denoted by an n by n matrix and let B to be denoted as an n by p matrix, the product of AB is defined by the m by p matrix whose entry A sub ij is the sum of the corresponding products of the ith row of A and the jth column of B. A what? Let me explain. What we're going to do is first note that matrix multiplication is completely dependent upon the dimensions of your matrices. What they're saying is the following. The number of columns in the first matrix must be exactly the same as the number of rows in the second matrix. And if they are, then your product will be, you cancel out the ends and you're left with m by p. That's where this comes from. All right, now what do? You take the first matrix row and multiply it by the second matrix column and add all those products up to create just one entry. So what I like to do is to put my dimensions below the matrix, either below here or when I'm multiplying and I write them out here, I'll go 2 by 3, 3 by 2. Notice that the 3's are the same. Cancel them out. My answer is a 2 by 2 matrix. And I like to build an empty matrix. 2 big blanks for the rows, 2 big blanks for the second row, and we're going to fill them in based on the definition. The other thing I like to do is to rewrite the matrices down, because to follow this rule, A sub 1, 1, first row, first column, you take row 1 of matrix A and you multiply it by column 1 of matrix B. So 2 times 4 plus 1 times 8 plus 3 times 5. Now when you write this out, I strongly recommend all the column numbers be put in parentheses. All the row numbers are out in front of the parentheses. So when we have a bigger matrix to multiply together, or for an answer, you're going to see a wonderful pattern that's going to speed this up. The setup is quick and easy. All we have to do is crunch numbers. Remember, you will have to do this by hand on the test and show all this work here. So I know that you know how to multiply two matrices together. All right, so if we want to crunch the numbers, we're going to get 8 plus 15, that's 31. Let's move over to row 1, column 2. All right, so row 1 again of your first matrix, but now we multiply it to the second column. So 2 times negative 7, again, these are going to be in parentheses, plus 1 times 6 in parentheses, plus 3 times 9. Crunch the numbers, negative 14 plus 6 plus 18, 19. Now, what's going to be nice is what you want to do is take all these numbers into parentheses, your column numbers, and just copy them straight down. I'm not going to do that. I'm going to keep following the definition, but you're going to see why I want to copy those down. When I want to get to row 2, column 1, now 1, negative 1, 0 is multiplied by the 4, 8, 5, which are in parentheses. So 1 times 4, negative 1 times 8, 0 times 5. So you copy those parentheses all the way down, then you just put the row numbers in front, and you're good to go. We can crunch the numbers here. We got 4 minus 8. Don't worry about the 0. That's a negative 4. Now, row 2 of A times column 2 of B, copy all the parentheses numbers down. Then we just put the 1, negative 1, 0 in front of those parentheses. Your 1 times negative 7, negative 1 times 6, 0 times 9. Crunch the numbers, negative 7, negative 6, added together is negative 13. And there's my answer. Now again, what I would recommend that you do is type in matrix A as a 2 by 3 into your calculator, type in matrix B as a 3 by 2, and tell the calculator you want to do matrix A times matrix B in the home screen and double check that your numbers are matching up, and they are. Okay, same two matrices. I'm going to reverse this. B times A. Over here was A times B. You're going to notice something very interesting when we switch the matrices around. So now B is first, A is second. It's a 3 by 2 times a 2 by 3. Okay, the 2's are the same, cancel them out. Now my answer is a 3 by 3 matrix. Matrix multiplication is not commutative. The order in which you multiply matrices matters. Okay, so here's my 3 by 3 empty outline matrix. We're going to start that pattern again. Row 1 of B times column 1 of A. So 4 times the 2, again in parentheses, plus -7 times the 1 in parentheses. Now, again, thinking ahead, you should right now copy down the 2 in parentheses all the way down, copy the 1 all the way down. I'm not going to do it on my screen. I want you to see how this pattern is going to work when we're all done. So just write those down. Next, row 1, column 2. That's this entry. 4 times 1, -7 times 1. Again, put the column numbers in parentheses. Once you write that, copy the parentheses and that number in the parentheses straight down. Give you a sec. Got them all copied? Good. Next, we're going to go row 1, column 3. Same 4, -7, now multiplied to the 3 and the 0. Again, column numbers in parentheses. Once you have this written down, now copy those column numbers all the way down. They're going to be the same. All right. Next, we're going to go to row 2. So row 2, column 1, 8 and 6, now multiplied by 2 and 1. See, there's that 2 and 1 lined up. We just have to put the 8 and 6 in front of what you had here. So 8 in front of the 2, then plus 6 in front of the 1. Now you got your 1 and -1 there. Put your 8 in front of the 1, plus 6 in front of the -1. You have your 3 and 0 here. Put your 8 in front of the 3, your plus 6 in front of the 0. You just put in the row numbers in front of your parentheses, and now that row is done. Okay, now we'll go to the third row. Now we're doing the third row of B times the first column. That's your 2 and 1 that you have there. Put the 5 in front of the 2 plus the 9 in front of the 1. Here's your 1 and -1. Put the 5 in front of the 1, the plus 9 in front of the -1. Here's your 3 and 0. Put your 5 in front of the 3, put your 9 in front of the 0. They always stay the same going down the columns. The numbers in front stay the same going across the row. And once you understand and see this pattern, this is going to be no time for you to write out and off to the next problem. All we have to do is crunch numbers. So 8 and a -7, that's a 1. 4 plus a 7, that's 11. 12 plus a 0, 12. In fact, we're going to get all zeros over here. So we'll just multiply the first part. We have 16 plus a 6, that's 22. 8 minus 6, that's a 2. 24. 10 plus a 9, 19. 5 minus 9, -4. 5 times 3, 15. There's my answer. Again, you go to your calculator. We already stored it from the last one. We just reversed it. Matrix B times matrix A. Double check to make sure your numbers are all right. They are. You're perfect. You got it all right. Okay. Next, we're going to talk about the identity matrix. This looks familiar. Remember in our Gauss-Jordan elimination method, in that augmented matrix, we had that downhill diagonal that was all ones, and zeros in the lower left-hand corner, zeros in the upper right-hand corner. That's called the identity matrix. It is a square matrix. So if you take this identity matrix and you multiply it to any other square matrix, you get the exact same square matrix back. So this is like multiplying a number by 1. Okay? All right, your inverse matrix. If you take matrix A and you multiply it by its inverse, or the inverse of A and multiply by A, this is the only time matrix multiplication is commutative, when you're finding the identity matrix as the answer. That's it. So what we're going to be asked to do is, they'll give us two square matrices, and they're going to ask us, are these inverses of each other? Well, to test it, you just multiply the two matrices together. So 3, 1, 2, 1 times 1, negative 1, negative 2, 3. Multiply together. 3 times 1, row 1 times column 1. 3 times 1, 1 times negative 2. Copy down the 1, copy down the negative 2. 3 times negative 1, 1 times 3. There's the negative 1 and 3. Your column numbers in parentheses. Copy them down. Second row is 2 and 1. Put the 2 and the plus 1 in front of each set of parentheses. Crunch the numbers. 3 minus 2, 1. Negative 3 plus 3, 0. 2 plus negative 2, 0. Negative 2 plus 3, 1. That's the identity matrix. Okay?